In machine learning, we use a set of feature variables to predict the likely value of a target label. A trained model is essentially a function that takes the values of these features and computes a result, which is the predicted value. One of the challenges with this approach is the opacity of this function, or in other words, the degree to which the inner workings of the function can be seen, understood, and explained. This opacity depends quite a lot on the class of algorithms used to train the model. We can think of models landing on a spectrum, from those that have less opacity and are easy to explain, for instance on the left, to those that have more opacity and are very difficult to explain on the right. All models will land somewhere between these extremes. For example, decision tree algorithms produce the lowest opacity trained models, which are essentially self-explanatory because you can inspect the entire chain of decisions that led up to any prediction. At the other end of the spectrum, we have deep neural network algorithms, which tend to produce the most opaque models, which are essentially a set of numeric weights that are quite difficult to understand and explain, even for the experts. Okay, so far it's been a lot of theory, but let's start to get a little bit more practical. One of the most important aspects of model explainability is feature importance, which tells us, for each input feature, how important it is in its contribution to the resulting predictions. Take, for example, the task of predicting the number of bike rentals. Some of the features we might have in this data set when predicting the number of bike rentals could be season, month, hour, if it's a holiday, if it's a weekday, the temperature, the humidity, and the wind speed. We want to use these features to predict the number of rentals. Once the model is trained, we might find out that hour may be highly important in the final prediction, while the weekday, less so.